Hello everyone, thanks to join me on this talk. I will present you today the device tree overlay and the U-boot extension board management. But first, let's talk about me. So I'm Köry Maincent, I'm an embedded Linux engineer at Bootlean for 1 year now. I worked with embedded Linux, U-boot, Linux Kernel, and few build systems like Yocto, Buildroot, or LEE2. I am developing BSP for projects and also help client on support. I have contributed to the extension board management to U-boot and also in another project to the Ubuntu support to LEE2. And I am living in Toulouse. What is the agenda of this talk? So first, I will introduce you the device tree overlay. First, I will talk a bit about device tree, but I hope all of you know about device tree because you need to know a bit about device tree before watch this talk. So then I will talk about device tree overlay, the principle, the syntax, and the current support in Linux or U-boot and U-boot. We will take the example of beagleboard.org to use overlay for its Cape extension board. And I will talk about the extension board manager that I have implemented in U-boot. So, as I said before, you need to have a small knowledge of device tree, but I will introduce it rapidly. So device tree is the data structure that describes the hardware components and the topology of an embedded platform. It is for now implemented on majority of CPU architecture, and so if you want to have more knowledge about it, or if you don't know about device tree, please see the talk of Thomas Petazzoni, and you can follow the link here to see its talk. We will use on this talk we'll use this example. So this example has the two nodes, RES and OCP, and a new subnode of OCP, which is a peripheral one. So if you don't understand this device tree description, please read about device tree. Now, let's talk about device tree overlay. So what is a device tree overlay and what is goal? So its goal is to modify a loaded kernel device tree. Speaking about modifying, so with an overlay we can add, remove, disable, adjust, add parameter to node, to existing node. So you can do the same action as you can do with the device tree. So in practice, in which case it is interesting. So the first case and the case we will speak about later is to load the overlay that match an extension board that is plugged on a main board. So each extension board is overlay device tree, and so when you plug on a board you can load the right overlay, and you don't need to write one whole device tree for each, the main board plus the extension board. And the second point on where the device tree overlay is interesting is when you are using FPGA. So you can describe in the device tree overlay what API are programmed in the FPGA region. So you can have one overlay for each API FPGA. To the device tree overlay syntax, so there is old syntax and new syntax. I will just speak quickly about the old syntax. In the old syntax, we used a word like fragment, target, and overlay to specify how the overlay will deal with the kernel device tree. But for in the new syntax, it is we will use the new syntax because it is more it is easier and it is more logic, because it is like write a device tree. It has the same description, and we don't need to use like fragment or overlay or target like the old syntax. So in this example, to specify, we don't try to resolve the node name like OCP. We have to add the plugin parameter to the device tree overlay syntax. So in this example, we just add the bar node subnode to the OCP node with its compatible parameter and whatever property or parameter you want. So the OCP is we are matching the label node of OCP, but we also can match the node path of OCP, like this syntax. Depend on what you want. To compile the overlay is quite simple. You just build it like normal device tree with the device tree compiler binary. But you have to know that we use .dtbo naming to match the device tree blob overlay. So, for example, if you want to compile the bar dash overlay .dts device tree, we just have to write this command. Just to see this, the result. So I have jumped the bar overlay device overlay, yes, with ftd dump command, and the result is the same for the old syntax and the new syntax. So we can conclude that the device tree compiler is changing the new syntax and to use the old syntax name. But we don't need to use anymore the old syntax because the device tree compiler does it for us. Let's talk about the device tree overlay support in the Linux kernel. So actually there is only the internal kernel API to manage the overlay. there is no user space API. So this internal kernel API will deal with the overlay syntax. There is no user space API because there are some RAM issue or some security issue. So various of them have been proposed over time but never merged. So you can find it easily on the internet, the one of the API proposed, and also some downstream constructor kernel could use this custom user space API, but it's not in the mainline. So as I say, some subsystems are not prepared to load the device tree dynamically in the after login in Linux, and it could break something. That's why never one of the API was never merged. So the device tree overlay is managed in U-boot because the overlay is applied before anything is loaded in the kernel device tree. Before the kernel load anything from the actual device tree, so it's easier to handle overlay in U-boot. For that, we use the fdt command, and the apply subcommand is the most interesting subcommand because it allows us to apply whatever overlay to the kernel device tree. This fdt command has been contributed by Butlin in 2016. The use case of beagleboard.org and its capes. I think you have heard of it, but beagleboard have several main boards like Beaglebone Black or Beaglebone AI, and we can plug a lot of cape on this board. So it is a point where the overlay device tree are interesting. Indeed, each cape has an EPROM filled with the identification data of the extension board. This EPROM is accessible over E2C. Beagleboard made a U-boot patch to read the EPROM and allowed the overlay that match the identification of the extension automatically. So Beagleboard manage the cape automatically. You just have with their patch. They manage the cape automatically. We just need to plug the board and U-boot detect it. But their patch are not mainline, and it was our job to push it mainline. So, but I will talk it later. Another use case for Beagleboard is to make cape compatible with different baseboards. So a cape compatible with the black or the AA baseboard. The issue, not the issue, the important things to take into account is that the two boards have different hardware, so the node naming are different. For example, the E2C1 for the black is linked to the E2C bone 1, and for the AI board it's E2C5. So the overlay have to be different because to match E2C1 or E2C5. To avoid that, Bagel board have chosen to use a divisive wrapper to change the name of the node, like alias. So we can see that in the overlay, if we use bone E2C1 or it will match either the E2C1 of the black or the E2C5 of the AA, of the Beaglebone AI. Now, let's talk about the extension board management in U-Boot. So I have implemented a few times ago a generic extension board manager to avoid this platform-specific U-Boot script used in Beagleboard, as I have talked before. This series of patch have been merged upstream in master next, and it will be available in the 2021.07 release. This extension board management implement 3 subcommands: scan, list, and apply. The scan subcommand detects the available board, the plugged board. The list subcommand lists the board that have been detected and list more information about it. And the apply subcommand apply the device tree overlay that match the extension board plugged. So it does the work automatically. You have to know that the extension scan command calls for a board specific function to enumerate the extension board, because we don't know where and how to get the information of the extension board. It is each constructor has its own solution. For example, the Bagel board use a prom on in square C, and the chip board from Nextthing.co use a prom on one wire. So we have to use the board specific function. This function will read the EPROM and fill the information table used by the extension command. But it will be clearer with a demo. So it's showtime. I will just use the board that you see in photo. So it's a Beagleboard AI base board with 3 capes, relay, fan or other, but don't measure. So I have put my board, and now I switch on the serial. So you can see that is Beagleboard AI, and I stop it on the U-Boot prompt. So first let's see the usage of the extension command. You can see the three subcommands: can, list, apply. Apply can, as you can see, apply can either load all the overlay or only one of the overlay. So we will have three overlay that can be loaded. So we can apply all or only 1, 2, or 3. So, but let's see it. So first, scan subcommand. So we found the 3 extension board. We saw their name and their E2C addresses, but this print came from the board specific command. But we can see more with the extension list command. It will show the information table that have been filled with the board specific function. So for each extension, you can see the vendor, which is beagleboard.org, the version, and the device tree overlay. This is what is interesting us. This is what is interesting. So each extension have the matching overlay. Then we have to apply the overlay. But to apply the overlay, we first need to load the device tree. This loads the device tree in the memory. Then we have to load the device tree in U-boot. We have to tell U-boot that the device tree is here in this address. Now it has been loaded. We could apply the extension, but to apply this the extension device tree, the overlay device tree, we have to know where these device tree are saved and how we can read them. So for that, the extension command need 2 variables. So extension address and extension overlay command. As you can see, the extension overlay command is the command to load is a command that load the overlay with using the extension overlay name that will be filled with the extension command. In this case, this address is the same as this extension overlay address. So we can see that the extension overlay command will load the overlay device tree from the MMC number 0 part 2. So we can indeed apply we can apply the overlay device tree. With this command, I apply only the second device tree, and if I use apply all, it apply all the device tree. Now just have to run the boot command, and all the kernel device tree plus the free overlay device tree will be sent to the kernel that will deal with it. Here is some reference from that helped me on the slides, and if you have any questions, suggestions, or comments, we will move on to that part. Thanks for watching.